What's going on? Welcome back. In today's video, we are going over a hard and difficult machine. The machine name is Charon. As you can see, the writing is kind of difficult, and actually it's a great learning experience. There is a multitude of things to learn on this machine. So basically we will bypass SQL injection filters, upload filters, get access to the machine, decrypt some encrypted keys or passwords, and at the end we will reverse engineer a file in which we will understand how it works. After we understand how it works, we're going to be able to exploit it and employ it for our advantage, which is gaining root access. So let's get started. So the first thing we do all the time is nmap scan. Nmap scan reveals we have two ports open. One is for SSH and one is for HTTP. As you can see, the HTTP title is revealed, frozen yogurt shop. So you go ahead and launch the browser and navigate to the machine. 3, 1. So upon navigating to the machine, we see kind of yogurt shop, as you can see here. And now, actually, I am kind of craving these things once I saw it. Anyway, so here we click on About, navigate through the blog, and we find different aspects. So here we can see it's powered by Super CMS. Now, if you go to the internet and find the login page of Super CMS page, let's see here, Super CMS documentation, I prefer. So there is no, okay, let's click on that. All right, I remember I found a page which lists all the directories on this CMS, but anyway, let me click on source, email exceptions, models. Okay, so here we have a page. Okay, now if you click on view page source, we find nothing of interest to our scenario. Now, basically, we can also try to, as I said earlier, find an exploit for this Super CMS, but unfortunately we don't know the version. And when we do not know the version, we cannot just go ahead and try every single exploit. We have to adapt to the methodology of pen testing in real life. We cannot just try exploit on the system, right? It may interrupt the business operations. Although this is not a business scenario, but here we're talking about the methodology. So basically, let's use directory search. If you use directory search, the following command sudo go buster -u 10.10.10.31 -w. If you use that word list, okay, you will find the login page of the CMS. Now, let's get back, and I'm not going to run directory search. Since this is a big difficult challenge, there is more stuff to focus on than just focusing on enumerating and finding the directories. So basically, let's get back here and type CMS data. CMS data is forbidden. Now, if we go to login page, and this is the login form. So the first thing we try all the time, as you can see here, we try first with SQL injection for login forms. Now, if you try to use SQL map, okay, and specify -- forms to find a vulnerability in this form, SQL map will fail to find you, actually because the form is not vulnerable to SQL injection. Rather, the forget password form is vulnerable. If you type single quote here, it's saying incorrect format. All right, now let's test this forget password form and see how it is vulnerable to SQL injection. And this is the request. So basically, this is, as you can see, because I typed a single quote here, it shows up in the email parameter. Now, this doesn't work, right? If we try something like test at test.com with the SQL code here and intercept the response. So see here, let's we have some error, I guess. Error in database. So this means that we have a SQL injection vulnerability. Now, in order to test this out, we have first to find the number of columns, right? And actually, if you try to take the request here, let me get back to the request. Where is the request? Forward. Let me reload the page one more time. If you take this request, all right, and put it with SQL map, unfortunately, it's not going to work to find the vulnerability. So we have to do that manually. So the first thing we do, we try to find the number of columns and use union injection for this. So we get back to the same scenario, test at test and we say something like order by 1, 2, 3, 4 and see the response. Error in database. Okay. Forward. Let me get something straight here. Let's intercept the request bit and intercept the responses all the time. I don't want to do this all the time, every time I intercept the request. So, all right, so test at test.com. Let's do this now seriously. Send, take the request, send it to repeater. And in the repeater, we play with the request however you want. Now, the first thing here, put single quote and let's try union select. So union select 1, 2, 3, 4, and to comment out to avoid the errors. So send, and we have an error. Now, if we try, this means that we have kind of filter taking place, because if union select didn't work and didn't retrieve didn't retrieve the columns here, okay, it means that there is something filtering the union. So there is a page. Let me show you the page here. SQL injection bypassing web application firewall. So here there are possible techniques we can use to bypass web application firewall according to the scenario. And one of the techniques discussed here is the union injection. So if we type union, we can play with the uppercase and lowercase of union to bypass this. So I guess this is it. Replace keywords. As you can see, they play with the lowercase to bypass it. So let's get back here and try it. So instead of union, all uppercase, what you will try instead, you will try UN, and the rest is lowercase letters. Let's try this one. Send. And what do we get? Incorrect format. So now we get different thing, right? Previously we got error, now we get incorrect format, which means that something is working here, right? Now, to make sure that everything is working as expected, we will replace 4 with an email address. Now, if the response was positive, like sending the password reset link to this email, right? It means that the union select injection works. So test at test.com, send. Again, we get error in database, so it means that doesn't work. All right, so here, let's try and put double quotes here. and see if this works. Oh, as you can see, email sent to test@test.com, which means that the injection worked. Okay, we are able to use one of the column numbers here to place an injection. Okay, so now let me get back here and open a text document in which we will craft the SQL injection payloads. So sudo nano SQL txt. All right, so let's get back here and copy that. We don't write this every time. And paste it. So here, that's all right. That's the first payload. The second payload could be something like, as you can see, test@test.com, then union select 1, 2, 3. Now we decide the next payload. So the next payload should be determining the name of the database, right? After determining the name of the database, we want to find out the name of the tables and the columns so we can retrieve the sensitive information, if any. Now here we have to adhere to this formula in order for this to work. The formula here is sending a password reset link to an email. So the payload must contain an email in a form or another. All right. So for this to happen, we have the payload. The payload should have the form of an email address. Now, what we will do, we will put a payload and join the payload with an email address like this. So in order for this to happen, we will have to use the concat. The concat is joining strings together in SQL. So concat. In concat, we specify two parameters or two strings that will be joined together. All right. Now, since here we're talking about an email form, all right, the first, let's put like this. Okay, the first string here will be the payload. The second string here will be the email, all right? Now, when we join them together, it will look like an email address, but at the back end, it will be executed as a command. So how this can happen? Let's say, for example, put the email test, at test.com, all right? And here, the first string here will be the command. So first command we'll have to understand, we will have to execute is the database name, finding database name. So database. All right, that's the first one. Let me copy it. All right, the next payload, after determining the database, we will have to find out the tables. Okay, so basically here, in a set of database, it will be table name, find the table name from information schema. So here from information schema.tables, where table schema equal here, it will be the table name, the database name. So retrieve the tables, right, from the database name that will be found from the first payload. Now I'm going to leave this right here and craft the second one. The second one will be finding out the number of columns. So what we will have to change here is the table name. Instead of table name will be column name. For information schema.columns, and here will be the name of the table, okay, from which we will be extracting the columns. Let's apply these payloads and extract information first. Let's take the first one. Take this part only, and here replace it. Let's see now the database name. Oh, we forgot to add the comments. All right. So send. Email sent to supercms@test.com. Now, Test.com is the part that is related to the email form. Super CMS, as you can see here, it is the name of the database. So Super CMS now is the name of the database. Now we get back to the console and we modify this to be Super CMS. Now, second, we will extract the number of, or extract the table names. So here, all right. Okay, send. User not found with that email. Table name at base.com from information SQL tables where table name equals super CMS. I guess we have to limit the number of results. So table name, all right. And here we say limit, let's say to 1. So we limit the number of results. Maybe this will work. Send. Email sent to operator. So the table number 2 is operator. If we put 1 here, license. If we put 3, user not found with that email. So we have only 2 tables in the database Super CMS. One is license and one is operator. Now we get back here, and table name here will be operators. One time will be operator, and another time will be license operator. So next we will extract the columns from this table, and of course I will limit the results to be, let's say, first 1 1. Our aim is to arrive to the username and password columns. Once we arrive there, we won't care what does exist other than that. Send. Error in database. So select 1 2 3 concat column name at test.com from SQL columns where table name, where table schema, operators, I guess. S. Send. Again, we have another error in database, table schema, table name, not table schema. All right, so here it is, column. All right. Email sent to username. So actually we have the first, as you can see, column in the table operator, which is the username. Now we will need this to extract the details from that. So let's take this username, and let's now extract the who is the username, who is actually the username. Let's put it like here. All right. Now here will be, let's copy this one, and let's modify on it. All right, so here we will cancel all of this part, and here column name will be username. So we will extract the value of the column username and specify from which table, from operators and limited. Let me try this. super CMS add ADM. So this is the username, I guess. ADM. All right, let's take this and here paste it. Now we will see what is the second column of the table operator. So we will get back here and take this one. Again, modify this to be operators, and here will be table name. Limits will be 2. Display the second column. Actually, it will be the password. So password underscore underscore password underscore. All right, so let's now find the value of this. Two, and here will be password. No, actually, I think it's enough to leave this one. And the password is, okay, we find it. All right. So this seems to be, we have to decode this. This hash is kind of MD5 hash. So let's decode this hash. And now intercept is off. Let's use hash killer online to decode this hash. Hash killer. My initial guess is this is MD5 hash. So hash cracker MD5. Found. The password is tomorrow. Tomorrow. So let's now go to login. Here is the password. The username is supercmsadm. Let me in, and we are in. Now that's the first milestone in this challenge: exploiting or bypassing SQL injection filters. Actually, exploiting SQL injection. It's not actually a real filter. All right. So our next aim is to upload something on the page. So as you can see, upload image file. Click on upload image file, and you will see here a way to upload files. Now, my initial guess, actually, it's not my initial guess. When I first did the challenge, my initial guess was that we can upload, there is a bypass, not bypass, sorry, there is a file upload filter here. Because as I guess, I assume that the challenge is not easy, and that's why we have to upload only image files. So let's first create a payload in PHP format, and we will convert this payload into some form of a GIF form to be an image by changing the magic number. And I have a video. Let's create the payload first. Sudo -p. Now this machine is not OSCP, that's why I'm going to use exploit, easier. -f row. And now let's hop to the browser and find the magic number of GIF. Magic number GIF. What happened to the payload? The payload has been created. Now let's copy that to a file. Shell paste it here. Now let's find the magic number of the GIF. No. Let's see here. GIF format. This is the magic number. Now let's get back here to the terminal and type x edit shell. So what we will be changing here, let's get back. 1, 2, 3, 4. The first 4, we'll make them adhere to the GIF format. So 4749, not this one. So here 4. What's happening? Oh, read only lets me, or sudo hex edit. So 4, 7, 4, 9, 4, 6, 3, 4, 6, 3, 8. Yes. Save that. Shell s. So this is the shell file. Now file shell. As you can see, it's saying it's GIF image. Let me open the file and see the file has not been tampered with. Nano or sudo. Okay. So we have this part. I don't know where did it go. Let me copy it again. File, still GIF image. Fine. Now let's get back to the upload form. And before we go ahead, let me establish or create the listener. Myself cancel. Okay, now here, a good idea or a good rule of thumb before testing an upload form is to inspect the page. View page source. As you can see, we have the upload form. Action is upload.php, method is post. On submit, as you can see, the validation JavaScript return validate this if it is an image or not. Now here we have a hidden input, hidden field. This field, actually, we have to uncomment this field, right? And invert the space 64 to the actual string. And instead of hidden, we will type equal file something, right? So let's get back here and see the intercept. All right, forward here. So let me uncomment this line. And we will convert this into a string. Test file 1. So this is a hidden field in the form. Let's uncomment this field, all right, and see what happens. So here, test file 1. Yes, and here, type equal, not hidden, name equal file. Let's say name equal file. All right, forward. So see here, a new field has appeared. Now if we type something in here, let's say file PHP and try to upload the payload. The payload is in here. It happened. Alright, submit. Sorry, CFake path is invalid. Allowed extensions are JPG. Alright, so we have to rename this file. I know it changed magic number, it should work, but also we have to do another part, which is changing the extension. Shell. Okay. Now, where is it? Submit. Seems like it worked. Now, here you see the file.php. Forward. As you can see, the image or the shell has been uploaded successfully. But there's a problem. The GIF is a problem here. So we have to find a way. But it will not be executed if the extension is a GIF. So I guess we will have to revisit the form one more time and change the logic of the word. So here we will again uncomment this and this one. So we remove the type hidden all at once and type here test file 1, test file 1 as it is, forward. Okay, so here let's choose the file, which is alright, so it is shell, and here and you will put the file name that we would like our file to have once it is uploaded. So let's say it is shell3.php. Yeah, where's the submit button? I guess I have to read this one more time. Upload, intercept, forward. Test file 1, forward. Okay, choose shell3.php. And now when we submit, the shell will be uploaded as shell3.php. The name will be, if it is uploaded successfully. I hope so. Submit. Alright. And it has been uploaded successfully. So that is the that's the trick here. We will have to use the hidden field as an to input a name of our file after we, of course, cover it in a image file. So we will have now to make sure the listener is running. Let's see here. All right. So now remember, I guess I forgot what I have did here. I have done. Let's go up. I used PHP payload. Okay, so we will create a PHP listener. Fine. Set or use. And run. Now we will navigate to the file. Hopefully it will work. So here, CMS, or let's navigate to uploads, images, shell PHP. And it worked. So that marks the second milestone of this challenge, bypassing upload filters. All right, next step now is the privilege escalation. So first thing we do all the time, sysinfo. It is Linux, Charon 44081. All right. Now, as you know, when we get access to a machine, right, or a target, we first try to find out what is in the home directory. So cd home, pwd, no, ls. So we have decoder, ls, and we have two interesting files. Decoder.pub and pass.crypt. Seems to be a public key, and this is the user flag. Seems to be public key, right? Let's get it. Decoder.pub. As you can see, this is the public key. And let's get pass. An encrypted key, right? And this is actually a short key to encrypt the public key or encrypt the password of the SSH access. So basically, we can decrypt this key easily using RSA tool. So let's go to RSA tool. Requirements. RSA multi-attacks tool. Uncipher data from weak public key and try to recover private key. Automatic selection of best attack for the given public key. So weak key public key factorization, which is actually the case. It is short, seems to be weak key. So what we will do here, we will just download the tool to our machine and launch it against the files. So let's take this. And let's download the public key and the password for the PUP. Download pass script. So where is this tool? So it is here. Now let's go to RSA and launch the tool. Dash public key. Specify the file. Where is it? The name of the file is decoder. Desktop. All right, and then let me get back, see what is the other option. Dash public key, dash uncipher file. Seems like we forgot something here. So the public key is right decoder, and then dash uncipher file. Where is the file? Pass. Let's see if it's gonna work. Nope. The module named. Okay, let's install this module. So the Oh my god, what's that? Alright, anyway, let's run this tool now. One thing to note, guys, if you try to execute the tool and you get an error that this module doesn't exist, all right, you have to install it. And if you get an error while you're installing the GMPY tool module, you'll have to install the where is it? The command. Okay, you will have to execute this command to install the dependencies of this library because it's a C library in Python. And if you can't install it, just execute this command, it will work. Now next we execute the tool. See, we have an error again, unrecognized arguments, home. Decoder. Dash public key. All right, so here it's not public dash key, space key is public key. Let's see now it's gonna work. So successfully we decoded and cracked the key. And as you can see, here's the password. But from the password, we see the string that we're supposed to take from this. Never mind the bullocks. Bullocks is a British word. So let's take this and try to log in to the SSH server. But actually, I'm just wondering what is the username. It will be decoder. All right. So let's split the view here. SH decoder at 10:10:51. Yes, the password. And now we have access to the SSH. All right. So the next thing is, which actually is marking the third milestones of this challenge, decrypting weak public keys. Now the fourth milestone is privilege escalation. So let's find about the binaries that have the suit bit set. Directory not existent. All right, find. So one interesting file is supershell. So we will have in some way to transfer this file to our local machine. Now the reason for this is the mechanism of this how this file is working. So basically, if you try to execute this file, see how it works. It's saying the usage is supershell and then cmd. Fine, supershell, and then let's say who am I? As you can see, it didn't work. Type ls also didn't work. So it's not actually taking the comments. So we will have to do some analysis on this file. Clear here. Yes. Now let's transfer this file to my local machine using netcat. All right. So here nc-lvp, or let's do it on the same command or the same view here. Split to the like that. All right. So here nc-lvp 454, let's say 7, and super shell. Now we transfer this file and see my machine is 10. Oh, I have to find the ID one more time. Port 4547, and we take the full path of the file to transfer it to my local machine. All right, so okay, it's here. Now let's start the analysis on this binary of file, supershell. So it is executable file 64. All right, so to see why when we supply a command the program is not executing our command, we will have to do some reverse engineering on this file. We'll have to open it in a debugger to inspect the code and to inspect the low-level language of it. So we use radar to supershell, no radar. Okay, now we will type 3A's to start the analysis. Now our aim is to inspect the main function. Okay, so here is the file. Let's see why it's not working as we want it to work. So it starts from here. So let's see here. I guess we need to open this on a bigger window. Let me cancel this one. And new window here. Okay, radar 2. Start the analysis. Analyze the main function. Okay, great. Now, as you can see here, guys, we go up. As you can see here, it prints the usage. Now, when it prints the usage, when we supply wrong arguments. As you can see here, very beta, which means that we supplied wrong arguments, and we need to find out what is the criteria for supplying the right command. So here call string copy. All right, here's string copy. We're gonna do this. Let's go down. Okay, here it is. So move ESI string bin ls. As you can see here, it's doing some comparison, as I understand. If the supplied arguments contain bin ls, right, it executes. Okay, so this means that let's try to supply bin ls, right, to the arguments and see if this work. So here we are back. Let's take this one more time. no, what's happened here? Shell. All right. So, okay. According to the analysis here, we have to supply bin ls. Bin ls. Let's supply it alone and see if we get something. Indeed, as you can see, it listed the files of the current working directory. If we type pwd, we are in the home, and in the home, in the decoder directory of home, as you can see, we have these files. So the program actually, what it does, it only lists the files and directories in the current directory. So here, if we want to execute that again, let's say we want to list the content of the root directory, we'll have to supply it with the directory. So here, root, as you can see, it actually listed the contents of the root directory, which contains only the root file. Now, how can we use this to create another shell or escalate the privileges? So we will have to use the concept of the subshells. The subshells, we can run the command in the subshell, right, to create another subprocess. The subprocess or the command will be passed to the supershell program and execute whatever we want. So we'll have to use the concept of subshell and subprocess. Or the subshell actually that we will create now, it will create another subprocess against the ls. So let's paste this. All right, bin ls, and we have to supply backslash. Let's see where's my backslash. Well, let me take it online. My keyboard has many languages, and it's hard to find out the correct. Okay. $, and here let's say ID. Now, what will happen is executing the ID in a subshell that will create a subprocess. So ID, so that didn't work. No, it worked. So ID is UID root. Oh, I don't like this. Let me change this to, let me copy that. Yeah, the output is not good. I don't like the output. Let's type OMI. Supershell. Very beta. Bin ls OMI root. I don't think it worked as intended. Okay. Let's do something meaningful other than ID, right? So here, let's cat the root file, the root.txt flag, see if we can list its content or read the content of it using the cat command. Cat root.txt. It worked. So this is the root flag. Now the question is, we want to escalate the privileges, right? So I understand now that we are the root here. ID here. Decoder, but when we do this here with the subshell, of course, the subshell, because it has a suit bit set, so whatever it executes it as root. But what we want here, not only the flag, we want actually to, escalate the privileges and be the actual root user. So we will have to write some code here. So let's get back to my machine. And exit radar with here root escalate.c. int main void What we will do here, this program will change the UID and the GID of the current user to the root user. So as you know, UID of the root user is 0, and the GID of the root user is also 0. So what we will have to change here, let's make it sh, and make the file name a bit easier. So escalate only. Escalate is here. Upload interpreter. And here's escalate. Now we will have to do the work of changing the permission one more time. Yeah, it's weird. It's very weird. I didn't like the last part at all. Alright, now change the permissions. Let's make it u plus s. Okay, execute. Permission denied. How come? Very beta. One more time. Okay, it worked now, IT. And we are the root user. And that marks the fourth milestone of the challenge, reverse engineering the executable, understanding how it works, and employs it for gaining access to the root user. I hope you like this challenge, and see you in the next video.